By the end of this presentation, the listener should be able to understand the methods and procedures used to correlate load pressure and thermal contact resistance. Surface roughness is the small bumps and depressions that exist on the surface of objects. When two objects come into contact with each other, it is these bumps that are actually contacting each other, resulting in small caverns which are filled with the surrounding fluid. Thermal contact resistance is the resistance that occurs because of surface roughness. As the heat is transferred between the two objects, there are two heat transfers in parallel that take place. One happens because of the material in contact, and another because of the fluid at the interface.
In the experiment, two plates of aluminum were placed in the MTS machine as shown. The top plate was heated by a resistance heater being fed a constant voltage and amperage. A load was applied using the MTS machine to compress the plates together. The system was allowed to reach equilibrium, upon which the temperatures were recorded. The plates were then compressed to a greater pressure, and the process was repeated. As the loads increased, it was assumed that more material would be in contact at the interface between the plates, which would result in a higher heat transfer rate. The graph shown takes data from Fundamentals of Heat and Mass Transfer 6th edition textbook, based on experimental data for aluminum being compressed in a vacuum. It shows the contact resistance decreases as the load pressure increases. A table of our results is shown, where when about 40 kilonewtons of force was applied, the heat flux reached 760,000 watts per meter squared Kelvin, and when nearly 80 kilonewtons of force was applied, the heat flux reached around 750,000. Not much of a difference considering the force was doubled. It can be observed that the loading condition played no role in the total resistance across the two plates. The temperature difference was expected to decrease more dramatically as the compression force increased. This was not the case. While the difference in temperature did decrease over the span of the experiment, that decrease was not large enough to affect an observable result.
After resistances were calculated for each load condition, the resistance across the interface between the plates could then be calculated. At first, the results were not encouraging. All of the contact resistances were zero. Upon further inspection of the book, the realization was made that the loading conditions were simply not enough to influence a significant change in heat transfer rates to thereby observe a contact resistance. Using the equations shown in previous slides, it was determined that the contact resistance is a function of 6 different variables: temperature difference from top to bottom of the system, temperature difference that happens from one side of the interface to the other, the conductivity of the material, the conductivity that is the result of the material and fluid in parallel, the surface roughness, and the length or thickness of the plates together. The end result is a dimensionless group being the function of 3 different ratios. Temperature, conductivity, and the lengths all contribute to this pi group. Each ratio relates what's happening to the whole system with what is happening at the very small interface. The dimensional analysis did not obviously include a term for the pressure. It turns out that surface roughness is a function of pressure. As the pressure increases, the material will start to deform. This serves to increase the material in contact and decrease the space occupied by the interfacial fluid. Essentially, the surface roughness decreases. Heat transfer will then increase, resulting in a decrease in contact resistance. Using a 25 micrometer surface roughness, the experiment was modeled in SOLIDWORKS. Again, the results showed that the load pressure was not enough to have a significant effect on the contact resistance.
The forces of compression were not strong enough in the experiment to realize an appreciable contact resistance. In general application, thermal contact resistance can be considered negligible. However, Under extreme loading circumstances, thermal contact resistance should be considered.